Okay, we have two vectors here, and the question is to find the unit vectors that are perpendicular on these vectors. Now, those vectors can be represented something like this. So you have the one vector there, the other vector there, and then there's a vector perpendicular on on those vectors, and then obviously the one opposite um, that vector perpendicular on the other vectors on the other side is also a perpendicular vector on those vectors. So the first thing is we need to do is to find at least one of the perpendicular vectors, and to do that you'll need to do the cross product. But let's call this one A and that one we call B. Okay, so what you need to do is to work out the cross product, and you can write that in the matrix form, and that is 1 minus 1 1. So those numbers are just that the A vector coordinates, and then the B is just 0 4 4. And okay, so now we do the cross product. First of all, if we work out the I, then you take these four, you probably know that, but then it's and then you multiply cross, so it's negative 1 times 4, it's negative 4. Then you subtract the multiplication of those, so it's negative 4i. Okay, then now the next term must be a minus. Okay, so let's go, that's a minus. Okay, so then if you take j, now you take the other two. So let's see. So you take um, those two in the sense of those four, but the two columns opposite or next to j. Okay, so j you'll calculate as again the 1 times the 4, and subtract the 0 times the 1, and that's just 0 j, and then the third term is just a plus, and then you take the other two columns that's left, so you'll take those two columns, so it's 1 times 4, and it's negative 0 times negative 1, so it's just 0. Okay, then if you simplify that, you will have negative 8j, negative 4j, and then you have plus 4k. Okay, so to calculate, so this vector we have here would be now typically that vector perpendicular on the two vectors that were given. So that would be typically that vector, and this one will be that vector. Okay, so now we have 1, so now we just need to calculate the other vector, and that's just the negative of this A cross B. So the negative of A cross B is another perpendicular vector on those AB vectors. Okay, so now let's calculate that. Okay, so the negative of A cross B is just the negative of this one here. So it's basically just negative 8i. Sorry, this must be I. 8i, obviously, because there's an I there. So 8i, and then you have negative 4j, 4k. So the result is just positive 8i, positive 4j, and then a negative 4k. Okay. Now the question is to get the unit vectors now, because we have the two vectors now. We have this one and that one that's perpendicular on A, B. So now we need to get the unit vector. So that's just straightforward. So now, so what you do is you first of all calculate the magnitude of this vector. So what's the magnitude? Well, is the magnitude. Okay, let's start with the A cross B just to do it systematically. Okay, so the magnitude of A cross B, oops, straight line, is equal to square root, and you square that one is negative 8 square plus negative 4, so that negative 4 squared plus just 4 squared, and if you work that out, it comes to square root 96, which is the same as 4 square root 6. Now this magnitude, what you do is you take the magnitude and you divide it basically into that cross product to get the unit vector, because this remember this cross product is just this one here. Okay, now you divide the magnitude into the cross product to get the unit vector. Okay, so that will be then 1 over 4 square root 6, and the unit vector is well, negative 8I plus 4j plus negative 4j plus 4k plus 4k. Okay, and then what do you have? Well, so you divide this into all of those coordinates, and then it's going to you're going to have negative 8I divided by 4 square root 6 plus, oh, remember this must be a negative, remember that. Okay, let's get that to be a negative. Okay, so that's going to be positive, well, again a negative. Okay, negative 4j over 4 square root 6, and then it's plus 4k over 4 square root 6. Okay, so how are we going to do that then? Well, so just simplify. So you have negative 2I over square root 6, because the 4 goes into 4 once and the 4 goes into the 8 twice. Then there you have, well, that cancels out, 4 and the 4 cancels out, so then you have negative j over square root 6, and there the 4's cancel out again, so it's k over square root 6. Okay, now this is the one unit vector. So now we still need to take that concept of the cross product divided by the magnitude, and we need to apply it to this, the negative of the cross product, which was the other perpendicular vector. Okay, so basically what we do is you say the magnitude of negative a cross b. Okay, you take that and you divide it into the negative of the cross product b. So basically, the magnitude of the negative of the cross product will be the same as the magnitude of just the cross product. And the reason why we see that is when you look at this new cross product that you got. Let me take another color. This cross product you got there, it differs from the original cross product, okay, just in terms of signs. But now anyway, when you calculate the magnitude, well, you square every term there, or the numbers, with its sign, so it will always be positive, and that's why this one is the same as the magnitude of a cross b. Okay, so then it's quite easy. So we know it's going to be 4 square root 6, and then this cross product, or the negative of the cross product, which is the perpendicular vector on AB, is now just this one. So we just put it in there. So it's 8I plus 4j minus 4k. Okay, let's go take it a bit down. Okay, and then what do you have? Well, it's 8j over 4 square root 6 plus 4j over 4 square root 6 negative 4k over 4 square root 6. Okay, so then that cancels out, that cancels out, that cancels out, and it's 2. So it's 2I square root 6 plus j over square root 6 plus k over square root 6. Okay, and this is the other unit vector then.